Good afternoon, dear colleagues. My name is Vasyl and I want to report of the topic automated energy efficient system for cleaning and disinfection of reusable objects. Introduction. First slide. Automated cleaning and disinfection of containers and containers with residues of various organic and inorganic substances, bacteria, mold and fungi is widely spread in agriculture, utilities, animal husbandry, and the other production areas. Usually cleaning is carried out by using the combined action of preserving water, liquid disinfectant, solution of chemicals, automated rubbing and drying, with the purpose of the internal and external cleaning of bags, boxes, containers and other reusable objects. It is extremely important to ensure the sanitary cleanliness of containers and containers for some vegetables and fruits for long-term storage of carrots, beets, cabbages, and the exactly winter varieties of apples. At the same time, big box plastic containers are used, which is indispensable in agriculture when the harvesting, when sorting and processing vegetables and fruits. Ventilated walls and the bottom ensures good air conclusion, keeping vegetable and fruits fresh. But their advantage during repeated use can be realized only in hygienically clean containers. According to the data of the God's farm, losses the horticulture products during storage can reach 5 to 7% of the total volume laid down for crop storage for the entire storage period. The main cause of apple loss are bacteria and fungi that remain on reusable containers. Therefore, carrying out preventing work on the pre-treatment and the containers cleaning and the disinfection contributes to reduce losses and increasing economic benefits to the process of sorting horticultural products. State of the problem. A well-known tunnel installation for washing and cleaning various items and reusable items, racks, plastic boxes, variety cages for animals, cereal trays. The installation consists of the transport platform, several technological chambers, section for the preliminary operation of cleaning, washing, rinsing and drying. During this operation, water, steam, warm, drying air and the waste of introduced into the removed from the respective chambers. The disadvantage of such an installation are complexly and multifunctionally significant energy consumption and cost, which is limited, and possibility of disuse only with the significant amounts of processing capacity. Simply similar European system for internal and external cleaning and the disinfection of containers with residual foreign substance are also known. The installations have a similar structure and include a closed tunnel with the transport conveyor line and the separate functional technological section, where the outer surface of the container is treated with the foam generated disinfect solution and rinsed. Then the inner surface is treated with the foam generated solution and rinsed. Considering the shortcoming of the considering system, the author said a task to simplify the technology's scheme and the cleaning the disinfection to include the use of the harmful chemical solution and elements and to increase energy infection. On slide 5 you see the description of the structural scheme of the system. The figure 1 presents the functional diagram of the developed system for cleaning and the disinfection of containers and small size containers and the other reusable items. On slide 6, description of the structural scheme of the system. Each of the sections is equipped with the sensor that ensure the control of the passage of the objects of processing to enable the corresponding technological operation. On slide 7, description of the principal operation of the system. On a figure 2, show the algorithm that describes a technological process of the cleaning and the disinfection of objects of repeated use. At the example, the process of processing containers and small-sized containers for storage and gathering products. The algorithm provides the full processing cycle and the shorted container processing cycle, right branch and the left branch, when the some operations are not advisable. The automated system works as follows, depending on the type of containers, its size and the level contamination, and the control panel sets the initial technological requirements for the impact parameters for each processing section and enters them to the computer. The dirty containers enters from the entrance zone 1 to the cleaning zone of the section 2, where the presence of the containers is detected by the sensor 6. The control unit 13 turns on and off for the programmed time the nozzle of the high pressure water supply, under the action of which the containers is rinsed. After rinsing, the containers is fed to the blowing and drying zone 3. The sensor A detected the presence of the containers into the section. The conveyor belt 15 stops and the containers are blown and dried. The infrared LED matrix, infrared LED with the wavelengths of 914 nanometers and the power of 10 watts, is used as the source of thermal radiation. As the microcontroller is advisable to use the Arduino platform and the simple available version of the LilyPad USB Omega 2560 boards with the clock frequency of 8 or 16 MHz. The authors paid special attention to the development of the ultraviolet for the fourth section. Usually bacterial energy insensitive mercury lamps and the ultraviolet action are used to provide typical facilities for the water disinfection, the swimming pools, various premises, medical instruments, and action. The power of these lamps can range from 50 watts to 1000 watts, with the luminous flux of 1800 lumen. The number of sources depending on the size of the radiation, decontamination objects is 4 or 6 pieces. Stopping at the minimum numbers of mercury lamps option is 4 pieces. We get the luminous flux of 7200 lumen and the energy consumption of 200 watts. To reduce energy consumption, the authors suggest replacing mercury lamps with the ultraviolet light emitting diodes, for example of the GNL 8003VC type with the power of 600 milliwatts and the luminous flux of 42 lumen. The ensure of the indicated luminous flux and technological condition, the number of the light emitting diodes is 180 pieces from the point of view of uniform irradiation. LED containers are grouped by 30 pieces and placed into the form of the 6 matrices. Slide 10 conclusion. The use of the modern electronic devices allows to reduce the consumption of the electrical energy by 30 and 40 due to reduction of the direct electricity consumption, time optimization of the processing technology process, first action mode of readings for the operation and electronic devices after switching on, and the possibility of the switching off, reducing the exposure of the processing cycle. Second is software management of the process of the preparing subject for the re-exemption, the use and application of modern electronic devices ensures complete automation of the technological cycle of the cleaning and the disinfection, and significantly reduces their processing time. Thank you for your attention.